consider a bold thought. Right now, the universe may already be over. The stars you see, this morning's coffee, your earliest childhood memory, each could be a fixed slice inside a finished block of space-time. What you feel as time passing might simply be your consciousness moving across pages that are already written. Tonight, we'll trace a path from Einstein's relativity, where time stands shoulder to shoulder with space, to a harder question. If life is a memory being replayed, what becomes of choice, of responsibility, and why do we still love, fear, and hope? Step softly into this thought experiment, not to believe, but to let the familiar world tilt a few degrees and reveal what it's been hiding in plain sight. Building on the idea that your life could be a path through a finished block of space-time, begin with the claim that our common picture of time may be wrong. Many people imagine time as a river that carries everything from past to future, but a different view says the past, present, and future can coexist, and that our sense of flow may come from how we experience the world rather than how the world is. This topic sits at the meeting point of physics and mind science. It asks us to look closely at what we mean by now, by memory, and by cause and effect. From birth onward, daily life seems to confirm a single direction. We remember yesterday, we plan for tomorrow, and we act inside a moment we call the present. The pattern feels so stable that doubting it can sound strange, yet the simplest way to approach the question is to treat that feeling as data, not as proof. The feeling could be a useful guide for survival without being a map of reality. Modern physics gives reasons to take that possibility seriously. These reasons are not fantasy. They grow from theories tested in laboratories and from tools that work only because those theories are right. If time does not flow the way we think it does, the change in viewpoint affects how we talk about choice, mind, and what it means for events to happen. The story of this shift began in the early 1900s and is still shaping research today. For a long time, cultures across the world built language around the flow of time. Verbs come in past, present, and future. Our feelings line up with that grammar. Regret looks back. Worry leans forward. Awareness settles in the middle. Causality, the rule that causes come before effects, seems to sit on that line, like beads on a string. Brains also reflect this pattern. Neuroscience points to networks that estimate duration, keep order, and mark before and after. The body runs on clocks that cycle with day and night, guiding sleep, temperature, and hormones. These are strong patterns, yet they do not prove that time itself flows. They show how living systems track change. The next step is to ask why such tracking evolved and what it tells us. Brains grew in a world where motion, prediction, and memory improved survival. Animals that could remember where food was and predict where danger might be had an edge. A sense of sequence helped with hunting, gathering, and care. Color vision offers a helpful comparison. The world is not painted. Color is how the brain labels different wavelengths of light so that fruit can be found and signals can be read. In the same way, the felt flow of time may be a label the brain uses to organize change, not a direct reading of the universe. History reminds us that experience can mislead. The ground feels flat. The sun looks like it circles us. A stone feels solid, even though it is mostly empty space between atoms. Space and time once seemed absolute, like a stage that never bends. Step by step, careful measurement overturned each of those beliefs. There is no special reason to treat our raw sense of time as the single exception. Work in cognitive science supports this caution. The present, we feel, is not instant. Signals from eyes, ears, and skin reach the brain at slightly different times. The brain stitches them into one moment, so that a dropped cup looks and sounds like one event. This stitching is fast, yet not perfect. In rare cases, a loud sound can be heard as coming before the flash that caused it. Medical cases show how fragile the sense of order can be. Damage in certain brain areas can break the ability to put moments into sequence, so events feel scrambled even when they are not. Other damage can lock a person into a kind of ever-present, where new memories do not form and the future cannot be imagined. These states do not prove that time does not have order. They show that the normal sense of order depends on machinery inside the head. If that machinery builds the flow we feel, then changing or failing machinery can change the flow without changing the world. Physics then enters with results that press the point further. In 1905, Albert Einstein introduced special relativity. In simple terms, the laws of physics are the same for all observers who move at constant speed, and the speed of light in empty space is the same for everyone who measures it. Those two ideas force a deep shift. One key result is the relativity of simultaneity. Simultaneity means at the same time. Relativity shows that two events judged to be simultaneous by one observer will not, in general, be judged simultaneous by an observer moving at a different speed. There is no single, universal now that runs across the whole cosmos. What counts as now depends on motion. This sounds abstract, but it has been tested many times. Particles moving near light speed decay more slowly than the same particles at rest, exactly as the math predicts. High-precision clocks on fast aircraft and satellites tick at different rates than clocks on Earth. The global positioning system needs to correct for these effects from both speed and gravity to give accurate positions on your phone. If engineers ignored relativity, location errors would build up quickly. The success of these corrections shows that time is not the same for all observers. With this, space and time merge into space-time, a single four-dimensional fabric. 3 dimensions measure length in different directions. The 4th dimension measures what we call time. An event is a point in this 4-dimensional map. Your walk to the door at 8 p.m. is not just at the door and not just at 8 p.m. It is at a specific space-time point. When we picture a whole set of points, like your entire life, we get a path through space-time. In such a map, the difference between past, present, and future depends on where you stand and how you move. The common picture is a landscape that already exists. Your mind moves through it, much like a traveler on a train, sees different mountains come into view while others fade behind. The mountains are all there at once. The sequence is in the seeing. This analogy is not perfect, but it helps to hold the idea without strain. If consciousness samples a 4-dimensional world slice by slice, then the feeling of flow comes from the sampling, not from the world changing into being. None of this erases cause and effect. Physics keeps strict rules about what can influence what. Signals cannot outrun light in a vacuum. Effects sit inside light cones, which are the regions in space-time that can be reached without breaking that speed limit. These rules hold inside the block picture. What changes is the status of now. Without a universal now, the flow becomes a local story about an observer's path. Many people hear this and think of free will at once. A fixed space-time sounds like a fixed future. The careful way to talk about it is this. The block view describes the full pattern of events, including the choices agents make and the reasons they give. In the map, those choices are part of the structure, just as fingerprints are part of a hand. From inside the life, those choices still feel open before they are made, and that feeling guides learning and planning. The map does not cancel the role of information, feedback, and intention. It places them in a larger frame. The brain science returns here with a practical note. The sense of decision involves many systems: attention, memory, prediction, and value. These systems work over short windows of time. The brain integrates evidence and then crosses a threshold. We experience the crossing as a choice. In a block picture, the whole process is a path in space-time with its own shape and timing. The power of the picture is not that it flattens life, but that it links personal time to physical time without pretending that now has to be the same everywhere. The history of science supports this kind of linking move. When people learned that Earth is not the center of the cosmos, daily life still went on, but the frame changed. When atoms were found to be mostly empty space, wood still felt solid, but we understood why. Here the frame shifts again. The present can be treated as a construct, built by brain processes that align with a physics where simultaneity varies with motion. This view explains why GPS works, why fast particles live longer, why some patients lose the thread of order, and why most of us usually feel a smooth flow. It also explains why the flow can bend under stress, fatigue, or drugs, because the builder is biological. The block view can feel cold, so keep the scale in mind. Space-time is vast. Your path through it is detailed, with fine structure at every moment: heartbeat, breath, thought, light on a wall. The detail does not vanish in this view. It gains location. Past events are not erased. They are earlier parts of a path. Future events are not misty things that do not yet exist. They are later parts of a path that other observers may slice differently depending on their motion. What remains constant is the rule set: how signals travel, how mass and energy curve space-time, how clocks tick depending on speed and gravity. Against that background, the brain builds a present to manage action. The result is a steady picture, a finished landscape in which local travelers feel motion and call it time. Eternalism, often called the block universe, takes the idea we just met and pushes it to its full shape. In this view, all moments past, present, and future exist within one four-dimensional structure called space-time. Nothing is waiting to be made real later. Every moment is part of the whole. The way every frame in a film reel already sits in place even before the projector runs. If this picture is right, the moment you are living now is real, and so are the moments you call yesterday and tomorrow. Your first breath exists, your last breath exists. Every win, every loss, every choice, and every result is part of the same completed layout. This sounds extreme, so it helps to ask simple questions. If all times exist, why do we feel movement from past to future? Why do we remember one direction but not the other? What does it mean for choice to matter if the future is part of the block? These are not trick questions. They are the natural next steps once we accept what relativity says about time. To picture the block, imagine a loaf of bread. The loaf is the full structure. Each slice is like a time slice that holds the whole spatial universe at one moment. No single slice is more real than any other. The slices exist together as one object. In the same way, space-time holds all the moments at once. The signing of a historic document sits in one region of the block. The fall of the dinosaurs sits in another. Your first day of school is there, and so is a day far ahead that you have not yet lived from your own point of view. The block does not say those moments feel the same. It says they share the same kind of existence inside the four-dimensional whole. Why take this seriously? Because it flows from the way time works in Einstein's theory. Once we learn there is no single, universal now, we can no longer mark one slice as the master present for everyone. What counts as now depends on motion and position. Two observers moving differently can disagree about which events line up at the same time, and both be correct in their own frames. This is not a guess. It shows up in data. Precision clocks, flown on airplanes and mounted on satellites. Ticket rates that match relativity's math. Particles pushed to high speeds in accelerators live longer than the same particles at rest. Navigation systems only work because they adjust for these effects. When the idea of time changes in this way, the door to the block picture opens. A mathematician who worked closely with these ideas in the early 1900s argued that space alone and time alone are not the real things. Only their union is. He was not just playing with symbols. He was stating a new way the world is stitched together. In that stitching, events are points in space-time, and world lines paths through the block belong to objects like you and me. Your life is a continuous path from your birth region to your death region. The path is not a metaphor. It is the set of space-time points that make up your physical story. If the block exists, where does the feeling of time's flow come from? A useful model is a spotlight moving across a dark field. The field is already there in full, but you only see what the beam touches. As the beam moves, it creates a sense of change. First this tree, then that hill, then the far ridge. The landscape is not appearing and vanishing. The light is selecting. In the same way, consciousness may be localized to certain regions of your world line and not others, giving you a sense of now that marches through slices in order. The order is real for you because your brain builds it as it samples one region after another. This model raises deep questions about mind. If brain states at different times are all part of the block, what is consciousness in this setting? Is it just the set of those states taken together? Or is it the active process by which some states become the current I am here, while others sit outside awareness? Some thinkers suggest consciousness could be a basic feature of reality that aligns with, but is not fully reduced to, the geometry of space-time. Others argue that mind is an emergent property of complex physical patterns, so that when the block has a certain kind of four-dimensional structure, the experience of a moving present arises from that structure. In both cases, the aim is to match what we feel with what physics allows, without smuggling in a global now that the equations do not grant. Identity also looks different in the block. Are you the whole four-dimensional object, the full world line from start to finish, or are you the experiencing subject at one slice? The first option treats you as the entire path, like a long twisted thread laid through space-time. The second option treats you as the consciousness that illuminates a local segment. Both pictures can live side by side. The path carries all the physical details: brain chemistry, breath rate, posture, words said and heard. The local experience carries the felt present. What we call growth is then the shape of the path. Later slices contain skills and memories that earlier slices did not. Nothing moves those memories forward. They are part of the later regions by the way the path is built. This helps frame death in a precise way. In the block, death is not a vanishing of the path. It is the boundary where the path ends. The full pattern of your life, childhood to last day, exists as a complete object within space-time. In that sense, your story is timeless inside the block. This is not a promise of survival after death. It is a statement about structure. The earlier parts and the later parts are all present in the same whole. People sometimes find this thought cold or comforting. The block itself does not tell you how to feel. It tells you what kind of object a life is. The same structure turns us back to free will and responsibility. If the future is part of the block, are choices fixed? The careful answer is that the block includes the choices as part of the pattern. Your deliberations, your weighing of options, your reasons, and your final act are all features of your world line. From the inside, before the act, the options feel open. That feeling is not a mistake. It reflects the brain building predictions and values before crossing a decision threshold. From the outside, in the full picture, the path includes the section where evidence is gathered and the section where action is taken. Agency lives in the connection between them. Responsibility can be tied to how information, goals, and outcomes relate along the path. To keep the level clear, think about how brains decide. Several systems work together. Attention brings in relevant details. Memory supplies, past cases, prediction estimates, results, and value systems score the options. Neural activity rises and falls until it reaches a point where one option is chosen. In a block universe, that rise, that crossing, and that action are stretches of the same path. The choice is not removed, it is located. What changes is not whether you decide, but how we describe where that deciding fits into the larger structure. The block view also addresses why we remember the past, but not the future. Memory is a physical process that stores records in brain tissue and in tools outside the body. Those records live in later slices and point to earlier slices. We do not have memory of the future for the same reason. The arrows of record keeping and heat flow point one way along our world lines. This aligns with thermodynamics, where entropy, the measure of disorder, tends to increase along the slices we label forward. The block keeps that arrow as part of the pattern. Lower entropy earlier, higher entropy later in the regions we inhabit. The increase gives us reliable traces of earlier states and a lack of traces from later ones. Experiments that first seemed like technical footnotes gain meaning here. When atomic clocks on planes came home running slightly slow or fast, they were not damaged. They were showing that different paths through space-time give different readings of duration. When particles moving near light speed decay more slowly, it is because their world lines stretch in a way that changes how proper the time along their path accumulates. These effects are not decorations on the theory. They are how we know the theory carries weight. If the block is real, everyday language needs care. We often say, the past no longer exists, and the future does not yet exist. In the block, those phrases are about access, not existence. You can no longer act on an earlier slice because your current brain and body are not located there. You cannot yet act on a later slice because your present systems are not located there either. What you can do is act where you are, and those actions are part of the path that includes their results. This way of speaking keeps our practical sense while matching the physics. Some people worry that a block universe makes life feel scripted. The worry fades a bit when we notice that scripts can still be complex, adaptive, and sensitive to information. In many systems, small inputs make large differences. Within your world line, learning changes later behavior. Feedback from others changes plans. None of that is lost. It is all inside the structure, as patterns of cause and effect that respect the speed of light and the laws of motion. The block is fixed, but it is not simple. It holds rich, branching order without a master timeline shared by all. Seen this way, eternalism does not erase meaning. It changes the map. Moments are not ranked by reality. They are arranged by relations. The present is the place where your systems are active. Memory and prediction link slices. Choice is the local process that ties reasons to outcomes along your path. Identity is the shape of the whole world line, while experience is the light that falls on one region at a time. Questions about agency and ethics remain real, but now they sit inside a space-time that does not privilege a universal now. And this is where the next set of problems waits. If our lives are four-dimensional patterns, how do we analyze freedom, blame, and praise in a way that fits both the physics and the lived sense of making a move? The block universe picture says that all moments exist together, yet we still feel a steady push from past to future. We do not watch broken cups jump back onto tables or steam gather itself into hot tea. Melted butter does not climb back into a stick. This one-way pattern needs an explanation that does not depend on wishful thinking or storytelling. The best place to look is the second law of thermodynamics. This law says that in an isolated system, entropy increases over time. Entropy is a measure of how many microscopic arrangements can make the same large-scale state. It is not just messiness. A perfect crystal, which is highly ordered, has very few possible arrangements of its atoms, so its entropy is low. A gas filling a room has countless ways to arrange its molecules while looking the same to us, so its entropy is high. Because there are many more high-entropy arrangements than low-entropy ones, systems tend to move from low to high entropy. That tendency gives us the thermodynamic arrow of time. The direction we call past points toward lower entropy, and the direction we call future points toward higher entropy. Memory formation also fits this arrow. To make a memory, the brain must create a stable record, a physical change that can be read later. That creation lowers entropy in a small region, like the pattern of connections between neurons, while the surrounding world increases in entropy even more. We remember the past because records about earlier states exist in later states. We do not remember the future because records of later states do not exist in earlier ones. If all moments exist in a block universe, what does it mean to say that entropy increases? One answer is to picture the block as already structured with an entropy gradient built in. Along one end of the space-time block, the states we call early have low entropy. Along the other end, the states we call late have high entropy. The second law then reads like a description of this built-in structure. Our experience of increase comes from moving along a world line that passes from regions of lower entropy to regions of higher entropy. This way of speaking shifts change into location. Entropy is not climbing as a process in time. Rather, the space-time map contains regions ordered by entropy from low to high. Consciousness, which is tied to physical processes in brains and bodies, is localized to regions where records point one way along that gradient. We experience a direction because our information gathering systems sit on world lines that run from the low entropy side to the high entropy side. The early universe makes this concrete. Observations show that the young cosmos was smooth, hot, and uniform on large scales. This smoothness corresponds to a very special, low entropy state when gravity is taken into account. The past hypothesis is the idea that the universe started in such a low entropy condition. In a block view, that low entropy condition is one end of the block, not a beginning that unfolds, but a region with special structure. The later side of the block, by contrast, contains high entropy states, where energy is more spread out and useful work is scarce. Cosmic expansion supports this picture. Space is stretching, and that stretch is speeding up due to what we call dark energy. As galaxies drift farther apart, it becomes harder for gravity to pull distant matter together to build new structures. Stars use up their fuel. Fewer new stars form. Over extremely long times, the universe trends toward a state where energy differences smooth out. That trend leads to the Big Freeze, a term for the universe's approach to maximum entropy. In this limit, stars have burned out, white dwarfs have cooled, and even black holes have evaporated through a slow process called Hawking radiation. Radiation spreads thinly. Temperatures approach a common low value, with no energy gradients left. No engines can run, no chemistry can drive complex cycles, and no new records can be written. The space-time regions near this end of the block look quiet on large scales, not because nothing happens, but because the possible changes do not support structure or information flow. In a block universe, that quiet end is part of the map right alongside the lively regions we occupy. The thought is stark. The region of maximum entropy is not waiting for us. It exists as one stretch of the four-dimensional whole. The region of very low entropy also exists as another stretch. Our lives run through the parts in between. This brings up a natural question. What happens to consciousness where entropy is maximum? If minds depend on ordered processes that create and maintain records, then a region with no gradients cannot support those processes. Consciousness would not travel beyond a point where the physical conditions needed for memory and computation are absent. Some thinkers have suggested that what we call the flow of experience is tied to the direction in which records can be formed. In regions with lower entropy behind and higher entropy ahead, records point backward, so we remember earlier slices and not later ones. That idea keeps the arrow of experience aligned with the thermodynamic arrow. Others have wondered whether consciousness could be more than a byproduct of matter's arrangement, perhaps a basic feature that helps shape which regions have low entropy in the first place. In that view, the entropy gradient is part of the same deep structure that allows minds to exist at all. These proposals are highly speculative. They sit at the edge where physics and philosophy meet, and they must be tested or constrained by evidence if they are to move beyond suggestion. For now, the safer claim is simpler. Wherever and whenever stable records can be built, the arrow of time lines up with increasing entropy, and experience aligns with that arrow. The story grows stranger when we add quantum mechanics. Relativity gives us the block. Quantum theory describes behavior at very small scales: atoms, electrons, photons. In this domain, particles do not carry sharp positions and speeds until measured. Instead, they are described by a wave function, a mathematical object that encodes a spread of possible outcomes. A particle can be in a superposition, which means multiple possibilities coexist in the description. The classic demonstration is the double-slit experiment. Send single particles, one by one, toward a barrier with two narrow slits, then let them land on a screen. If no one checks which slit each particle goes through, the pattern that builds up on the screen looks like waves interfering bright and dark bands. The pattern implies that each particle behaves as if it went through both slits at once. But if a detector is placed to find out which slit the particle uses, the interference vanishes, and the pattern matches particles going through one slit or the other. The act of measuring appears to pick one outcome from the many allowed by the wave function. This raises hard questions. What does a block universe hold if the small-scale world is described by superpositions? Does the block contain only the single outcomes we observe, or does it include all the possibilities the wave function encodes? One answer is the many worlds interpretation. In this view, there is no special collapse of the wave function. Instead, when a measurement happens, the total quantum state evolves into a superposition of branches. In each branch, there is a version of the observer who sees one definite result. All branches are real, but observers within a branch experience only their own result. If many worlds are real, the block is not a single loaf, but a vast branching structure of blocks. Each branch is a block universe with its own four-dimensional layout of events. Branching occurs whenever interactions entangle systems in ways that make outcomes effectively separate. The branching is not about human attention. It is about the physics of how information spreads and becomes hard to reverse, a process called decoherence. The implications reach from the early universe to your living room. Quantum events in cosmic inflation, in star formation, in chemistry, and in neurons could all contribute to branching. For every place where outcomes could have differed, there is, in this view, a branch where they did. There would be branches where clouds formed slightly earlier, where a lightning strike hit a different tree, where a synapse fired or failed in a way that nudged a thought. There would be branches where your life's path turned on small differences. There would also be branches so different that the familiar structures of matter never arose. This picture pushes us to ask what you means across branches. If there are many versions of you, each with a continuous world line inside a branch, which one is the subject of experience? A cautious answer is that the subject is always the local version inside a single branch. You do not feel the outcomes in other branches for the same reason you do not feel someone else's headache. The information that makes up your experience is confined to your branch. Identity becomes branch relative, tied to a particular four-dimensional path in a particular block among many. There are proposals that give consciousness a more active role, suggesting that experience might select a branch. These ideas try to bridge the gap between the formal math of quantum theory and the felt unity of a single timeline. Another line of thought treats the selection as an illusion produced by decoherence. Branching creates effective separations, and observers inside one branch cannot access the alternatives, so it feels as if a single outcome happened. In either case, the lived sense of a definite world arises, even if the total structure includes many worlds. How does entropy fit with branching? Decoherence produces record-stable correlations between systems and their environments. Those records increase entropy because there are many more microstates consistent with measurement has happened than with no record exists. The thermodynamic arrow thus aligns with the quantum arrow provided by decoherence. In branches where records form, observers remember earlier events and not later ones, and they see entropy rise along their world lines. The block with branches picture keeps both arrows pointing the same way, in the regions where complex systems, including minds, can exist. The double-slit experiment also highlights the role of information. When path information is available in principle, even if no one looks at it, interference fades. When path information is erased, interference can return. This quantum eraser behavior ties the appearance of wave-like or particle-like outcomes to whether the world contains records that distinguish the paths. Records are physical. They take up space, involve energy, and create entropy. The link between information and entropy is not a metaphor. It is a calculable relation in physics. That link helps explain why memory points backward and why we can act only in the local present. In a block universe with an entropy gradient and possibly branching, the sense of flow comes from where and how information is written. Consciousness tracks those records because it depends on stable brain activity. Where gradients allow records to form and be maintained, minds can exist and experience order. Where gradients vanish, minds cannot persist. These statements do not answer every question about mind or meaning. They mark the places where physical law sets the stage and where experience finds its lane within that stage. What remains is to connect these pieces to agency with care. If world lines are laid out in blocks, and if branching produces many blocks, then choices appear as structures in those blocks. The physics sets constraints. No signal faster than light. Entropy increasing along usable paths. Quantum outcomes correlated by the rules of the wave function. Within those constraints, decision-making systems gather data, weigh values, and act. The record of that process is part of the block structure. The next challenge is to analyze how responsibility, praise, and blame fit into that structure without relying on a universal now and without ignoring the arrows set by thermodynamics and quantum information. As we probe deeper into time and reality, we meet what philosopher David Chalmers called the hard problem of consciousness. This is not just about how brains process information or control behavior. It is about why experience exists at all, why there is something it feels like to be you, instead of complex processing taking place with no inner life. The problem sharpens when we set it inside a block universe. If every physical process, every brain state, and neural pattern exists as part of a four-dimensional structure, what is consciousness that gives rise to a sense of moving through time? Standard neuroscience treats consciousness as emergent. When billions of neurons fire in coordinated patterns, a subjective point of view seems to appear. This story can track attention, memory, and decision-making, but it struggles with the leap from function to feeling. We can describe how information flows, yet we still have to explain why information processing should be accompanied by any felt quality. In a block universe, another puzzle joins in. If all of your brain states across your life are part of the block at once, what ties the states into one stream? Why does experience come as a connected flow rather than as a scatter of unrelated moments? Why do you not wake up in random slices or perceive every slice at the same time? One answer moves consciousness from product to basic feature. Panpsychism proposes that the building blocks of nature carry simple, proto-experiential properties. On this view, brains do not manufacture consciousness. They organize it. The four-dimensional structure of your brain, its full pattern across space-time, could act like a template that shapes these simple elements into a unified field of experience. The unity you feel would then track how the pattern binds parts together, not a switch that suddenly flips consciousness on out of nothing. Another proposal is integrated information theory, IIT. developed by Dr. Giulio Tononi. IIT links consciousness to integrated information, the amount of information a system generates as a whole above and beyond its parts. A system with high integration has many specialized elements that also work together as one. According to IIT, the level and quality of consciousness match the structure of this integration. In a block picture, your stream of experience could be the subjective side of integrated information patterns laid out along your world line. The sense of flow would arise because information is integrated not just across brain regions, but across short stretches of time, knitting successive slices into a coherent field. These ideas raise questions about boundaries. If consciousness corresponds to integrated information, then very different systems could support very different forms of experience. Patterns might exist on large scales or long time scales that integrate information in ways unlike a human brain, that leads some thinkers to cosmopsychism or consciousness-first models. In those models, consciousness is fundamental, and physical law is the structured appearance of its activity. The block is then a structure within consciousness, rather than the other way around. The geometry of space-time would be how a cosmic mind organizes experience into regular, measurable relations. From Dr. Federico Fagan has argued from this direction, suggesting that quantum fields and particles could be mathematical shadows of interactions within a basic conscious reality. In his view, consciousness does not sit inside physics. Physics sits inside consciousness. All of this is controversial. The claims are bold and sit at the edge of current science. Still, the mix of modern physics with the mystery of consciousness forces these questions into view. As data accumulate, we can at least check which ideas resist observation and which ones fit with known measurements. Neuroscience adds concrete links between consciousness and time. Studies of patients with brain injuries show that awareness and temporal experience are not separate dials. Damage can leave a person alert yet unable to form new memories, trapping experience in a narrow present. Other injuries can scramble the sense of order, so events feel out of sequence even when the world is stable. Some people report an expanded now, where moments feel stretched, while others report that the present collapses to thin slices. These patterns suggest that the brain constructs temporal flow using specific networks. When those networks change, the quality of flow changes. This can be read through the block lens. If consciousness is the local process of sampling the block, then different neural states could correspond to different sampling modes. A normal mode would stitch slices into a smooth flow with clear order and duration. Altered modes would change the stitch, fragmented time, extended present, or loss of sequence could reflect differences in how records are formed and integrated. The block would not change. The way consciousness interfaces with it would. Quantum theory brings another layer. At small scales, systems are described by wave functions that encode many possible outcomes at once. In some interpretations, observation plays a special role. Consciousness causes collapse, suggests that when an outcome is measured by a conscious observer, the spread of possibilities jumps to one result. If that were correct, consciousness would help determine which physical events become actual in the experienced world. In a branching view, like many worlds, there is no collapse. The total state evolves into separate branches, and observers in each branch see a definite result. But even there, we can still ask what it is about observation and recording that gives the feeling of a single world. If consciousness selects outcomes, does it operate outside space-time? The question comes from timing. In a block universe, all outcomes already exist as regions. If consciousness picks one, is that pick part of the block or a rule that stands over it? A careful, modest answer is to point to decoherence and records. When information about an outcome spreads into the environment, branches become effectively independent. Observers inside one branch cannot access the others. The appearance of a single world follows from the physics of how records form. Consciousness, tied to those records in the brain, finds itself in one branch because that is where its information resides. Still, we can ask whether consciousness does anything over and above tagging along with records. IIT would say yes. Consciousness is the intrinsic aspect of a system's integrated causal structure. Panpsychism would say yes in another way. Consciousness is everywhere, in simple forms, and brains arrange it. Cosmopsychism would say yes, at the larger scale. The whole looks like a block because a fundamental consciousness structures it. Each approach must face tests. Does it predict patterns in neural data that we can measure? Does it explain why certain brain rhythms correlate with awareness while others do not? Does it tell us why anesthesia works the way it does? Or why sleep stages change the feel of time? Some connections are already tangible. Brain imaging shows that the binding of information across regions and milliseconds matters for consciousness. Disruptions to integration by injury, seizure, or drugs alter both awareness and time perception. Measurements of neural complexity tend to drop under deep anesthesia and in certain disorders of consciousness. These findings do not settle the hard problem, but they press any theory to account for how integration in time and space supports the stream of experience. Set back inside a block universe, the pieces align in a practical way. Records, entropy, and decoherence define where stable information can exist. Brains build integrated patterns within those limits. Consciousness tracks those patterns. The stream you feel is the local binding across short stretches, not a global river flowing through a changing universe. The past holds stable records you can access. The future lacks records you can read now. The arrow you sense matches the direction in which records accumulate, and entropy rises along your world line. Speculative models, like consciousness selecting branches or shaping the entropy gradient, try to go further. They aim to give consciousness a role that is not just passive. If such roles exist, they must leave traces, changes in statistical outcomes, unusual correlations, or testable limits on when decoherence behaves as expected. Without traces, the safer view is that consciousness rides on the same physical rules that set arrows and build records. The open tension remains. The block suggests that all your brain states exist as one four-dimensional object. Your experience insists on a single unfolding line. Bridging the two may require a framework that treats experience as the intrinsic side of integrated, time-bound structure, while leaving the extrinsic geometry to physics. The tools to probe that bridge already exist in labs that measure complexity, information flow, and time perception under controlled changes in brain state. The next move is to press these tools against the competing ideas and ask which patterns of evidence they can and cannot explain. If the block universe is real, if all moments exist together in the four-dimensional structure of space-time, then we have to ask, what becomes of agency and free will? In daily life, we feel like choosers. We face options, weigh reasons, and act. We feel uncertainty about what will happen. We sense ownership of our decisions and hold each other responsible. That That sense sits so deep in our picture of ourselves that to question it can feel like questioning what it means to be human. In a block picture, every decision you will ever make is already a fixed part of your world line. Tomorrow's breakfast choice sits there. Career turns sit there. Whether you start a family or live alone sits there. Nothing is waiting to be decided from the outside view. This can look like agency reduced to an illusion, the way a film character appears to struggle but follows a script. If consciousness only rides along, watching events in sequence, then the feeling of freedom might seem like a feature of the ride rather than a cause of the plot. The question sharpens when we define what we mean by free. One camp says freedom requires that, given the past and the laws, you could have done otherwise in the very same situation. Another camp says freedom is acting from your own reasons, values, and character, without coercion or defect. On this second view, often called compatibilism, what matters is that your action flows from who you are and how you think. Even if the full pattern of events is fixed, the block can contain both the reasons and the result. Your authentic motives, the evidence you consider, and the choice you make are part of one structure that does not erase freedom, it locates it. A simple analogy helps. When you rewatch a familiar film, the plot is fixed, yet the characters' choices still feel real inside the story. The debates, doubts, and turns have meaning because they reveal the character's aims and traits. In a similar way, your deliberation is a real process with a role, gathering facts, comparing outcomes, weighing trade-offs, and committing. Inside your world line, those steps are the mechanisms by which intentions become actions. The fact that the whole sequence is laid out in the block does not cancel the function of the sequence any more than a printed score cancels the music when played. Identity matters here. If all moments of your life exist, what is the you that chooses? One answer treats you as the full four-dimensional object, your entire world line from birth to death, rich with structure. Another treats you as the experiencing subject at a slice, aware of local states, while linked to memories of earlier slices and plans about later ones. These pictures can fit together. The world line carries the physical details and the information that later slices inherit from earlier ones. The experiencing subject is the local perspective built by the brain as it binds records and predictions. Growth and learning then show up as shape. Later segments include skills and insights gained in earlier segments. Nothing moves those skills forward. They are part of the later regions by design of the path. This way of seeing changes how we talk about moral responsibility. Harmful acts are fixed features of the block, but so are apology, repair, and change. Responsibility connects actions with the character and reasons that produce them. If you help a stranger because you value care, the act is praiseworthy even in a determined structure, because it expresses that value through informed choice. If you harm someone out of anger you reject on reflection, blame tracks that mismatch. Sanctions and praise shape later behavior by altering information and incentives. The block includes those feedback loops as well, embedded along the path where education, law, and culture influence what happens next. Neuroscience supports this process view. Decisions build over short windows. Evidence accumulates in neural circuits until activity crosses a threshold and action follows. Values encoded in networks of memory and emotion tilt the accumulation one way or another. In a block universe, those windows and thresholds are regions along your world line, Agency is the structure linking information, evaluation, and outcome. Freedom is not magic outside causation. It is the organized way a person's reasons become behavior in that structure. Quantum mechanics adds another layer. If the many worlds interpretation is right, reality branches whenever quantum events have multiple outcomes. Each branch holds a definite story. Each version of you follows a world line in its own branch. At first glance, that seems to help freedom by multiplying possibilities, but the details matter. Within any single branch, the story is still fixed from the outside view. What many worlds changes is the global picture. Across branches, every allowed outcome happens somewhere. Some thinkers suggest a selection role for consciousness. Your experience follows one branch rather than another. In a softer reading, no active selection is needed. Decoherence spreads information into the environment so completely that branches lose contact. Observers inside one branch cannot access the others, so it feels as if a single outcome occurred. Could your choices steer which branch you experience? If choices supervene on brain processes that include quantum-sensitive events, then slight differences might correlate with different branches. Still, from the inside of any branch, the experience is of a single line of outcomes guided by reasons. If we tie agency to the integrity of that guidance, clear goals, good evidence, coherent values, then responsibility holds at the branch level without needing a power to hop across branches. Other proposals give consciousness a more direct causal role. Some consciousness causes collapse. Ideas say observation by a conscious system picks an outcome rather than letting all branches persist. If true, this would place choice at the pivot of physical events. But such claims need strong evidence, stable deviations from standard quantum statistics, reproducible links between mental states and outcome frequencies, or precise conditions under which collapse occurs. Without those, the cleaner view is that quantum theory's branching plus decoherence already explains why we see definite outcomes and why memory points one way. There is also a radical path. Treat consciousness as fundamental, with physics as its structured appearance. On this approach, cosmopsychism and related views, the block is not a cage around mind, it is a pattern within mind. Space-time geometry would be the way experience is organized into regular relations. In that case, the contrast between free mind and fixed block might be a language issue. At the experiential level, choices are creative expressions of awareness. At the physical level, those same choices show up as fixed patterns in spacetime. The two descriptions track the same events from different sides. This move does not remove the need for tests, it shifts them. We would look for bridges from measures of integrated information and neural dynamics to reports of agency and to limits on when and how decisions can be altered. Even without a final verdict on metaphysics, the lived features of choice remain. Uncertainty, as felt from the inside, comes from limited information and limited computation. We do not know all the facts or all the consequences, so we simulate, sample, and decide that uncertainty is not fake. It reflects the state of the decision maker and the costs of gathering more data. Norms about responsibility work with that reality. Seek better evidence when stakes are high. Avoid bias, correct errors, and hold agents to standards that improve future behavior. These norms make sense whether the world is a single block, a branching set of blocks, or a structure inside consciousness. A useful way to test any view of free will is to ask how it handles interventions. Training can change habits. Therapy can adjust values and impulses. Laws can alter incentives. Feedback from friends can redirect plans. In physical terms, interventions change the information and conditions along your world line so that later segments differ from earlier ones. In moral terms, they help align actions with better reasons. If a theory of agency cannot explain why such changes work and how they matter, it misses what we need from a model of choice. We can also separate metaphysical freedom from practical freedom. Metaphysical freedom asks about ultimate could-have-done-otherwise claims. Practical freedom asks whether agents can act on reasons, resist coercion, and access options. Societies protect practical freedom by securing education, reducing manipulation, and designing fair rules. Those steps improve the quality of decisions across many world lines. They do not depend on settling the deepest metaphysical dispute. In the block picture, moral growth is not a march forward so much as a shape. Regions of regret and repair sit alongside regions of harm and error. Praise and blame belong to the links between reasons and acts within that shape. In many worlds, similar patterns play out in each branch that hosts complex agents. In consciousness first views, the pattern is how awareness makes structure. Across these frames, the common thread is that agency is a way information, values, and action hang together. A final point clarifies what illusion should mean here. Calling freedom an illusion would be like calling temperature an illusion because it emerges from molecules. Temperature is real at the scale where it works and can be measured. It is defined by its relations to energy and behavior. Agency can be understood in the same layered way. It is real at the level where reasons, evidence, and control interact, even if at a deeper level the world is described by fixed geometry or branching quantum states. Set against this fatalism, the view that effort does not matter does not follow. Effort is part of the structure that leads to outcomes. Better reasoning, clearer goals, and good information change what happens next along a world line by changing the local causes. The physics leaves room for that because those changes are themselves physical. The philosophy leaves room for that because responsibility tracks the link from reasons to results. These threads push us toward a working stance. Analyze freedom in terms of the integrity of decision processes, the availability of options, and the fit between values and actions. Map those features onto physical descriptions of world lines and, if needed, branches, and keep tests close to data from brains and behavior. From here, the discussion turns to how such a stance handles prediction and control, how far forecasts can go without erasing agency, and how to measure the limits set by information, noise, and quantum effects. Across history, people have wondered whether time is different from how it feels. Philosophers, mystics, and whole traditions have asked what eternity means and how temporal experience fits inside it. What is new today is that advanced physics reaches conclusions that rhyme with some of those old insights. The overlap does not prove that the answers are the same, but it does suggest that humans have long sensed that ordinary time might be a surface view rather than the base layer of reality. In ancient Greece, the Stoics argued for an ordered cosmos, guided by the Logos, a rational structure that fixes the whole of events. For thinkers like Chrysippus, what will happen is already woven into the world's pattern, yet they did not erase agency. They taught a clear split between what is outside our control and what is inside it, our judgments, our assent, our responses. The overall fabric could be determined, while personal conduct remained a matter of choice within that fabric. This is close to modern discussions about freedom in a block universe. The large-scale layout may be fixed, while the way a person aligns with that layout by reasoned acceptance or resistance still counts as agency. Hindu thought offers a wide lens on time. The Sanskrit term kala covers both sequential time and an eternal frame in which all moments coexist. In the Bhagavad Gita, Krishna grants Arjuna a vision of the cosmic form, where past, present, and future are seen together. The shock comes from realizing that events of the battlefield are already present in that larger view. It is not a simple prediction, but a picture of time held at once. That picture sits well with the idea of a four-dimensional space-time, in which different slices coexist inside one structure. Buddhism adds the principle of dependent origination. Phenomena arise in dependence on conditions, and those webs of conditions extend without a first start. Nothing stands alone, or at a single instant. The connection across what texts call beginningless time echoes how physics links events through space-time, not only by sequence, but by geometric relation. In both pictures, individual moments draw their meaning from a network that reaches widely. Mystical reports cut across several traditions and often speak of an eternal now. Christian writers like Meister Eckhart describe awareness in which all time is present. Sufi thinkers speak of waqt, a station beyond ordinary sequence, where the usual split between before and after does not hold. Ibn Arabi wrote of creation as an ongoing relation rather than a past event. From that view, the history of the universe and its final state do not wait in line. They are held together in a deeper order. These claims are not physics, but their structure resembles the claim that the block contains all events at once. While local observers experience a moving present, cyclical time in the East adds a different pattern. Hindu cosmology speaks of vast cycles: creation, maintenance, dissolution, and rest, repeating across ages. An ending is not unique. It is a repeating feature of the whole. In a scientific key, one might hear an echo of states that recur, or patterns that repeat at scale. Though modern cosmology does not require an eternal cycle, the philosophical move is the same. Treat endings as structural, not final in a single linear sense. The idea of eternal recurrence, sharpened by Nietzsche, offers another angle. He framed it as a test of life. Live as if every act would return again and again. While not a scientific claim, it has kinship with a view where all moments exist eternally. In such a view, each moment is both itself and, in a sense, always present in the full structure. The focus becomes authenticity within a fixed pattern, not escape from it. Recent philosophy of mind stresses a split between two standpoints. Thomas Nagel called them the view from nowhere and the subjective point of view. The first treats reality as a whole, described without preference to any observer. The second is the lived sense of being an agent inside time. The block universe pushes us to hold both, a timeless structure seen from the outside and a stream of experience seen from the inside. The tension is not a flaw to be erased. It is the cost of thinking at two scales. Theology raises parallel issues. If an all-knowing being knows every event, are those events fixed? Many traditions have wrestled with how foreknowledge and free will can fit together. The scientific question is framed differently, but rhymes with the theological one. If all space-time events exist, where does agency live? And how does responsibility make sense. The methods differ: revelation and doctrine on one side, measurement and math on the other, but the core puzzle is shared. Advaita Vedanta teaches that the ultimate reality, Brahman, is beyond time and change, and that the world of change is Maya appearance, shaped by ignorance and viewpoint. Maya is not fake. It is a way reality shows itself. This maps cleanly onto the idea that temporal flow could be how consciousness encounters a static block. The flow is not wrong. It is local and useful. The underlying structure does not move, but minds do. Many traditions say that seeing through the usual view of time brings freedom rather than despair. If the passing of time is a kind of dream, waking from it reveals a different kind of meaning. Values shift from chasing outcomes to understanding order, from fear of loss to clarity about place. In scientific terms, this can be read as moving attention from what seems isolated and urgent to what is structural and reliable. The overlap between old wisdom and new physics is striking, but it needs care. The sources of insight are not the same. Ancient texts use meditation, argument, and parable. Physics uses models that make quantitative predictions and experiments that test them. When we say the themes converge, we do not mean they collapse into one claim. We mean that similar shapes appear: an all-at-once picture, a local arrow of time, and an effort to place agency within a larger order. The block universe, as a scientific idea, comes from the union of space and time in relativity, along with evidence that simultaneity depends on motion and that clocks tick differently in different paths. It is supported by measurements of time dilation, gravitational effects on time, and the success of technologies that rely on those corrections. These are not visions or parables. They are instrument readings and working systems. The block does not rest on mystical claims. Even so, the convergence is notable. It suggests that human minds have long been pulled toward questions that pure common sense cannot answer. People have sat with the feeling that time's flow is not all there is, that a larger frame must exist. Today, the mathematical form of that larger frame is more precise, and the tests are stricter, but the itch is recognizably the same. We should also keep the boundary clear. Mystical claims are often about value, meaning, and transformation. Physics is about structure, measurement, and prediction. Where they meet, we can ask whether one can inform the other without confusion. For example, a report of an eternal now does not measure simultaneity across moving frames. A metric on space-time does not tell you how to live. A careful stance lets each domain do what it does best, and then looks for bridges that are honest about limits. As scientific models have advanced, the strangeness of reality has grown. Quantum theory tells us that particles can be in superpositions, that outcomes are statistical, and that interference appears when which path information is absent. Relativity tells us that time and space are flexible, that mass and energy bend geometry, and that there is no global present shared by all observers. Cosmology tells us that space itself expands and that far-off galaxies recede faster than light because the space between us grows. None of these were imaginable to earlier ages, yet the equations work and the data fit. Each step has carried us away from naive pictures and toward mathematics that does not map easily onto intuition. Quantum tunneling is a clean example. A particle appears on the other side of a barrier it should not cross by classical rules. The math predicts the rate. The devices that rely on tunneling like some electronic components, work as designed. But what it really means is hard to capture in everyday images. The lesson is not that understanding is hopeless. It is that the right level of explanation may be abstract, and that feeling comfortable is not a reliable measure of truth. This pressure toward abstraction shapes how we should hold the block universe. It may be the best fitting picture we have for how time and space knit together at large scales, yet still be a step towards something deeper. Quantum gravity, for instance, aims to merge the rules of the very large with the rules of the very small. In some approaches, space-time itself is emergent from more basic relations, like networks of information or quanta of geometry. If space-time can emerge, then a block could be a higher-level object built from something more primitive. Philosophy tracks the same move. The view from nowhere can be extended to include not only all events, but all branches, if many worlds is right, or all possible histories weighted by amplitudes, if path integral methods are taken literally. At the same time, the subjective view narrows to the local, embodied agent who acts on reasons and reads records. The task is to make these standpoints consistent without forcing one to swallow the other. Theological ideas about omniscience also shift under modern light. In a block, the notion that everything is known becomes a claim about what exists, not about prediction across a moving present. Knowing in this sense is access to the structure, not foretelling in time. The old puzzles about foreknowledge and freedom can be recast in terms of information, causation, and the integrity of decision processes along world lines. In Advaita terms, if Maya is the way reality appears to limited minds, then physics can be seen as a map of Maya's rules, the stable regularities of appearance. The larger claim that Brahman is beyond time would then sit outside the scope of measurement. The contact point is not proof, but pattern. Both insist that the flow is not fundamental, and both look for a frame in which the many becomes one. Many traditions report that grasping these patterns can change how people live. If outcomes are part of a larger order, worry may give way to clarity about what is within reach, attention, effort, and care. This overlaps with Stoic practice and modern compatibilism. Act well within the structure you inhabit, and let reasons guide you. The science does not tell you which reasons to choose, but it helps clear away confusion about what kind of control is possible. The open question is how far the present models reach. Each past revolution has revealed gaps we did not expect. It was hard to imagine that time could dilate, that space could curve, that vacuum could teem with fields, or that measurement could change what is observed. The next shift may again show that our current maps are local. Quantum theory still resists a single, agreed story. Interpretations differ on what superposition and measurement mean, yet the calculations match experiments with extraordinary precision. General relativity has passed every test in its domain, yet at singularities and at quantum scales, we expect it to give way to a deeper account. The block universe may capture the large-scale geometry while missing the mechanism by which geometry itself forms from more basic elements. None of this weakens the value of the block view. It gives a clear handle on simultaneity, causation, and the arrow of time when linked with entropy and records. It explains why different observers slice events differently, and why tools like GPS must correct for those differences. It situates agency at the level of information and reasons along world lines. It frames moral responsibility without relying on a global now. At the same time, It leaves room for the possibility that time, space, and even the block are emergent from something more abstract, where the pieces meet ancient insight, modern theory, and lived experience. We can chart questions that tests can reach. Which measures of neural integration best track the felt flow of time? How do entropy and decoherence set limits on memory and prediction? Which cosmological observations constrain the early low entropy state and the late high entropy fate? How do differing interpretations of quantum mechanics change what counts as a branch? And can any experiment tease those differences apart? The pattern that emerges is not a neat synthesis, but a working map. It marks regions where language from philosophy and mysticism parallels structures from physics, and regions where the methods part ways. It marks where agency can be analyzed in terms of information and control, and where deeper questions about consciousness still stand. And it points to the next task. If the block universe is a strong approximation, what deeper framework could contain it? And what observations would tell us that we have reached that next layer? What if the way we think about time, space, mind, and existence rests on assumptions that will look quaint to people in the future, push past today's borders, and other pictures come into view? Consciousness might not be a traveler moving through a fixed block of space-time. It might be the source that generates the block as a way to organize experience. The four-dimensional structure we treat as fundamental could be more like a user interface, simple, stable, and useful, built to help conscious systems navigate something deeper and more complex. Ideas from modern theory stretch this even further. String theory points to extra dimensions, hinting that our four-dimensional world may be a shadow of a space with up to 11 dimensions. The holographic principle, inspired by black hole thermodynamics, says the information in a region can be stored on its boundary, as if a 3D scene were encoded on a 2D screen. John Wheeler's It from Bit flips the usual order and makes information the base ingredient. Matter, energy, and even space-time become patterns in an informational substrate. In that frame, physical objects are not the bedrock. They are stable arrangements inside a deeper language of bits and relations. If reality is fundamentally informational, consciousness may not arise from information processing. Consciousness could be what it is like for information to be present to itself. The block universe would then be a data structure in a wider field of awareness, not a box that traps awareness inside. What seems like a timeline might be a way the field indexes and retrieves records. Digital physics goes another way, but rhymes with this picture. Some theorists propose that existence is a computation, not a simulation on a machine in another universe, but computation as the basic process. Time would be the execution of a cosmic algorithm. Laws would be the rules for updating states. Being conscious would be how it feels to be a particular pattern in that update, a local routine woven into the global code. The simulation hypothesis takes a step sideways. If advanced beings can run vast ancestor simulations, and if they choose to run many of them, then most observers would live inside simulations. From within a simulation, direct tests might not cleanly separate base from sim, but the deeper challenge is that the line between simulated and real may not be meaningful at the foundations. If consciousness is primary, then both physical and simulated worlds are modes of presentation, different ways awareness organizes experience. Some researchers in consciousness studies lean into that possibility. The hard problem why there is a felt inner life at all might signal that consciousness is not produced by physical activity, but is the context in which physical activity appears. If so, asking whether consciousness is inside the block or moving through it gets the order backward. The block would be inside consciousness. Space-time, causality, and objects would be the regular forms that awareness uses to present experience to itself. In that framing, the laws of physics are like the logic of a dream that is consistent, shared, and mathematically precise. Individual minds would be focal points of attention within a wider field, each lighting up parts of the shared structure. On this view, questions about whether time flows or has ended turn into questions about how consciousness chooses to structure its own creativity. The block might exist as one possible organization, while other organizations beyond our current imagination also exist. None is more real in principle. Each is a rule set for presenting relations and events. Neuroscience and psychology support the idea that our experience is constructed. Brains do not passively record the world. They predict, fill gaps, and build the most likely scene from limited, noisy inputs. Perception is a controlled hallucination, tuned by incoming data. We feel a stable world because our models are good at smoothing and stitching. Temporal flow can then be read as a modeling choice, a way a predictive brain represents change, not proof that time itself moves like a river. The brain evolved to keep organisms alive, not to reveal ultimate structure, so its models are built for action first, truth second. That pushes us toward a Kant-like map. We may live within the phenomenal world, the world as it appears given our cognitive equipment, while the thing in itself sits outside direct reach. Yet modern physics offers mathematical bridges beyond our native categories. Relativity and quantum theory are translation devices. They let us calculate and test aspects of the world we cannot picture directly. The symbols go where intuition cannot. In that light, the block universe could be a high-level chart that works in its domain, while pointing to a subtler base where even space-time is emergent. Whatever the base is, consciousness remains stubborn. Right now, there is something it is like to be you. Thoughts, sensations, and questions appear. You do not need a full theory of reality to know that awareness is present. Whether consciousness moves through a block, helps generate observations, instantiates as information processing in a cosmic computation, or stands as the ground from which physics arises, the fact of experience does not budge. In that limited but firm sense, a mind is the universe aware of itself from a particular address. Take eternalism seriously, and a practical puzzle shows up. How to live meaningfully if all moments exist at once? From one angle, your biography is part of a fixed geometry. Birth, choices, relationships, failures, and achievements are laid out in space-time. Change does not happen in an absolute sense. It is encoded as differences between slices. From another angle, you feel uncertainty, make plans, and work to change outcomes. You deliberate and care. These features do not switch off because a larger map exists. They are local processes that matter at the scale where living happens. This is the existential paradox of eternalism. If the whole path is complete, why does life feel open and unfinished? If the future is fixed, why does it feel undetermined? If time does not flow, why does consciousness present a moving now? One way in is through indexicals, words like I, here, and now, that make sense only from a position. Even if all events exist, experience is located at specific space-time points. From where you stand, later slices are not available to inspection. Your knowledge is limited to your causal past and the immediate present. That limited access makes uncertainty real for the agent, even if it is not a feature of the global structure. A spatial analogy helps. All places on Earth exist at the same time, but you see only what lies within your horizon. Distant cities are as real as your street, yet they are not present to you without travel or communication. Your view depends on where you stand. So too with time. Later events can be as real as earlier ones, but your current brain state only carries records of the past and models of the near future. Information from truly later regions has not reached you. The result is genuine uncertainty from the inside, within a deterministic block. That uncertainty is not fake or sentimental. It affects action, value, and planning. Agents form goals, gather evidence, and choose under limits. Those limits are built into how signals move and how records form. They are also built into how brains compute. The combination means that even in a world where the whole structure exists, the local work of deciding remains necessary. The feeling of openness matches the fact that from your position in space-time, you cannot read the later pages. You can only write the next line with the information you have. The paradox is not only about not knowing the future, it reaches into agency, responsibility, and meaning. If your choices are already part of the eternal structure of reality, can you still take credit or blame for what follows? If your growth is already encoded in the four-dimensional pattern of your world line, does effort still count? Some philosophers say yes. Meaning and responsibility can survive eternalism, because what matters is not a magical power to have done otherwise in an identical world, but whether your choices express your real values and come from real deliberation. The fact that your values and your thinking are themselves in the structure does not erase their role. When you help someone in need, the act is still praiseworthy if it flows from care and judgment. When you learn a new skill, the act is still meaningful if it is your mind engaging with new information and folding it into your life. This view shifts the focus from changing an open future to the authentic expression of consciousness within a fixed pattern. The pattern may be complete in space-time, but the experience of living it is not empty. It is the path by which a mind encounters, tests, and affirms what it stands for. Whether the pattern unfolds in a flowing timeline or sits as a finished geometry may matter less than the fact that, inside the pattern, consciousness meets each moment as real. Personal growth also looks different when seen as structure. Instead of picturing change as moving from one state to another in time, we can see a single four-dimensional life with earlier and later stages. The you who struggles and the you who overcomes are different slices of the same person. Growth is the shape of the whole, not a substance added from outside. In that shape, effort shows up as links between challenge, practice, feedback, and new ability. Those links are part of the architecture, not illusions laid over it. This can even deepen how we view hardship. If consciousness is experiencing a story that is already formed, then pain, confusion, and delay are not loose ends. They are necessary elements of a complete pattern that includes learning and repair. The point is not to romanticize suffering, but to notice that the structure holds both the struggle and what the struggle builds. Many people find comfort here. If the story is complete, then each hard stretch also has its resolution somewhere in the pattern, and each joy also has its place. Others see a threat in this framing. If the future is fixed, why try to improve yourself or help anyone else? Why strive if the outcome is already set? The worry treats predetermined. as if it meant imposed from outside regardless of what you do. In the block view, that is not what predetermined means. Your future includes your efforts as causes. The reasons you form, the plans you make, the work you do, all of these help shape the later parts of your world line. You are not outside your life, looking in. You are the system whose actions and reasons are part of what makes your life what it is. That leads to a sharper claim. Your choices do not matter less in a block universe. They matter so much that they are etched into reality's structure. Every act of kindness, every moment of courage, every careful thought or crafted work becomes a permanent feature of space-time, as definite as a constant in an equation. In a flowing time picture, actions fade into the past. In a block picture, actions are always present at their coordinates. Their significance does not wash away. This can increase the weight of care, not reduce it. Living with this stance asks for a shift in purpose. Instead of seeing life as moving from lack to fullness, you can see it as consciousness expressing and exploring a completeness that already exists. That does not force passivity. Inside the pattern, the process of trying, failing, and adjusting still happens. Discovery still matters. Effort still costs and bears fruit. The inner shape of striving attention, practice, feedback, improvement remains the way complex systems reach goals. The difference is that these processes are now understood as parts of a whole rather than as engines pushing the universe forward. For some, that shift inspires engagement. If each moment exists forever, then presence is precious. If each choice is permanent, then care with choices increases. The seriousness of attention rises, not falls. The value of small acts can grow, because nothing is merely on the way to something else. Each act has its permanent address. The paradox of timelessness begins to soften when you notice that the lived meaning of work, love, and learning comes from the doing, and the doing is part of the structure. A practical way to hold this is to separate two senses of change. At the global level, the block contains all events. At the local level, an agent moves through a sequence of states where information is gathered and actions are taken. Local change is what it feels like to integrate new data, update beliefs, and act on reasons. That local process is what we normally mean by growth. It is how a person becomes able to do what they could not do before. In the block, that ability shows up in later slices because earlier slices contain the work that made it possible. The logic is consistent without asking the universe to rewrite itself. This also reframes progress beyond the self. Helping others is not pointless because the outcome already exists. The help you offer is part of what makes that outcome exist for them. Your intervention advice, resources, presence sits along their world line and changes what is true in later regions of their path. Institutions, laws, and communities work the same way. Their structures shape countless lives by altering the information, options, and incentives that appear in later slices. Public action matters because the block includes the causal reach of policy and care. The worry that urgency vanishes under eternalism rests on the idea that urgency requires uncertainty at the cosmic level. That is not so. Urgency lives at the level of agents with limited information and finite time budgets. You cannot access all facts. You cannot act in all places. You must choose under constraints. Those constraints impart urgency because delay changes what is possible in your local future. The block view does not remove these limits. It explains why they exist. Information travels at finite speeds, records form in one direction, and brains compute with finite resources. If we adopt this stance, many guiding ideas still hold only their grounding shifts. Responsibility links actions to reasons and outcomes, not to metaphysical magic. Commitment means aligning choices with values across time, which in the block is aligning one stretch of your world line with another. Hope means orienting present effort toward later states you endorse, knowing that effort is one of the causes that make those states part of the pattern. Regret marks a mismatch you want to correct in the next stretch. None of these depend on a flowing present shared by all observers. A common fear is that seeing life as fixed will flatten emotion, but the intensity of feeling comes from stakes at the agent's scale. Caring about a friend's health, working to master a craft, standing up for someone, these are tied to concrete outcomes that change with your actions. The block includes those ties. Emotion tracks them. Even in a world with a complete map, the local terrain still must be navigated step by step, and the body and mind still respond to gains and losses. There is also a second edge to meaning. If meaning is expression of values through action, then meaning grows where clarity and skill grow. Effort matters because it refines both. Practice clarifies what you aim for and strengthens the means you use. Education widens the range of reasons you can see. Dialogue tests and improves them. In a block, these improvements show up as later regions that carry better habits and wiser judgments built from earlier work. The whole pattern is richer because those links exist. Seen this way, eternalism can support a wider compassion. If every life is a structured path with fixed joys and pains, then responding with care is not about changing destiny from the outside. It is about being part of the exact causes that make relief, learning, or justice true in later regions of another person's path. Your action stands alongside theirs as part of how the pattern holds. The idea of an eternal perspective follows from this. It is not detachment from time, but the ability to hold two frames at once. The timeless completeness of the block and the temporal, situated work of an agent. In one frame, everything that will be is. In the other, you decide under limits with the best reasons you can gather. Training this double view could change how choices feel. It can reduce panic without lowering care, and it can raise patience without erasing urgency. Whether such a shift in consciousness is possible is an open question, but some evidence hints at flexibility. Practices that improve attention and metacognition can change how people relate to thoughts, feelings, and time pressure. People report wider present moments and steadier focus. Neuroscience shows adjustments in networks that integrate information across short windows. These are small signs that our sense of time and self is, at least in part, tunable. What follows from all this is not a mandate to accept every outcome, but a guide for how to act within the structure you inhabit. Align choices with values you endorse. On reflection, seek accurate information. Build skills that widen your effective options. Take responsibility for how reasons become acts along your path and how your acts shape paths around you. The framework shifts how we explain meaning, agency, and growth, but it leaves their practice in your hands, where action, attention, and care still do their work because they are part of what the world contains. As our map grows, we have to ask where ideas about time, consciousness, and reality are heading. Science keeps widening the circle of what counts as possible, and philosophy works to make sense of what those results mean for how we live. The questions sound abstract, but they now guide real experiments, new instruments, and research programs that could change how humanity understands its place in the cosmos. In physics labs, teams are testing our assumptions about time and cause. Some experiments probe quantum retrocausality, where the settings we choose later seem to change the statistics of earlier measurements. These designs do not let us send messages to the past, but they do stress the simple picture of a single, clean order of events. The results force better questions about what before and after really mean when outcomes depend on full experimental contexts. Entanglement adds pressure of its own. When paired particles show linked outcomes across wide distances, the correlations hold even when signals between them would have to exceed light speed to coordinate. No useful messages ride those links, but the pattern is still strange. The pair behaves like one system spread across space. Some theorists take this as a sign that space and time are not the deepest frame. What looks separate in ordinary life might be connected at a level where the usual distances and delays do not apply. Gravitational wave astronomy gives us a new way to test space-time. Detectors that measure tiny ripples from colliding black holes and neutron stars already confirm parts of Einstein's theory with remarkable precision. As sensitivity grows, we may observe more exotic events. Rotating black holes, for instance, allow solutions that include closed time-like curves, paths that loop back in time inside certain regions. Whether such paths can exist in nature without creating paradox is an open question we can press with better observations. Work on consciousness is advancing in parallel. Neuroscientists are mapping how the brain builds temporal experience from streams of sensory data and internal predictions. They study how attention widens or narrows the felt now, how memory writes stable records, and how the brain stitches order across milliseconds. Philosophers of mind analyze how that constructed flow relates to physical processes. At the same time, a small but active line of research asks whether parts of brain function rely on quantum effects that do not fit neatly inside classical spacetime. Some proposals suggest that conscious systems might maintain or exploit quantum coherence, raising the possibility that awareness taps processes with non-local reach. If any form of quantum organization contributes to consciousness, it could help explain why subjective time feels like a moving window through a static block. Artificial intelligence approaches the topic from another angle. As systems grow more capable, researchers ask what a machine's temporal experience would be if it had one. A digital system can process many timelines in parallel and can run much faster or slower than a human brain. If artificial consciousness is possible, it might not feel time the way we do. It could integrate information across long spans without fatigue, or track multiple branching scenarios at once. Building such systems would not by itself answer the hard problem, but it could sharpen tests about how information structure relates to the feel of passage. Cosmology keeps refining the big picture. Better surveys of galaxies and supernovae, and more precise maps of the cosmic microwave background sharpen our estimates of dark energy and the fate of expansion. A universe that expands forever, cools toward heat death, high entropy, thin energy, little structure. Some models allow cycles, rebounds, or bounces that reset conditions. If cycles exist, a block view could extend without a single start or end, with repeated large-scale patterns written across vast temporal ranges. Theories of quantum gravity push deeper. String theory replaces point particles with tiny strings in higher dimensional spaces, and it has tools that connect strongly curved spacetimes to lower dimensional boundary theories via holography. Other approaches, like loop quantum gravity and causal sets, try to build space-time from discrete or combinational elements. Across these camps runs a shared idea. Space and time might be emergent. If space-time is not fundamental, then the block we picture could be a higher-level structure built from more basic relations, perhaps networks of entanglement or patterns of information flow. Black hole physics is a stress test for these claims. The information paradox asks how information about matter that falls into a black hole could be preserved if the whole eventually evaporates. Work on holography and quantum error correction suggests that information is not lost. It is scrambled and encoded in subtle ways on horizons and in outgoing radiation. If information is preserved even in the most extreme conditions, that strengthens the thought that information sits at a very deep level of reality. Some theorists go further and describe physical processes as information processing steps. In that picture, reality is computational in nature, and consciousness could be what certain computations feel like from the inside. Philosophy of mind follows with models that place awareness closer to the ground floor. Panpsychist views say that simple forms of experience exist widely and combine in complex systems. Cosmopsychist views say that individual minds are aspects of a wider, unified consciousness. These positions are controversial, but they aim to line up the hard problem with a physics that already treats information as fundamental. A key test for any such view is whether it can predict or explain measurable links between patterns of neural integration and the presence or absence of experience. Dialogue with Eastern traditions feeds practical work here. Contemplative neuroscience studies how trained attention changes the brain's handling of time, how meditation can stretch or thin the felt present, quiet rumination about the past or future, and alter the sense of sequence. Reports of suspended flow or widened now are paired with imaging and electrophysiology to see which networks shift and by how much. The methods are careful and gradual. Define the practice, measure baselines, track change over weeks and months, compare to controls. The goal is to build a catalog of modes of temporal consciousness and the brain signatures that match them. Tools that sit at the interface between mind and machine may expand those catalogs. Brain-computer interfaces can already read course intentions and feed back signals that shape attention and learning. In time, more precise interfaces might let researchers modulate the brain's timing networks directly and observe how the felt flow responds. Virtual and augmented reality already alter temporal experience by changing how inputs arrive and how feedback loops close. As those technologies become more fine-grained, people may be able to explore experiences like parallel timelines, slowed or accelerated perception, or non-linear narratives that still feel coherent. Each of these steps has social implications. As views of time and mind shift, ethics and policy may need to adjust. If people come to see their lives as four-dimensional structures rather than open-ended marches, responsibility will still matter, but the language for it may change. Education could place more weight on metacognition, training learners to notice how they form reasons under time limits, how they update beliefs with new evidence, and how they manage attention across overlapping timelines of work and rest. Health systems might use individualized temporal profiles, how a person's brain handles duration and order to tailor therapies. Research programs will continue to overlap. Experiments on entanglement inform holography. Holography informs black hole thermodynamics. Thermodynamics links back to the arrow of time. The arrow of time shapes how memory and prediction work in the brain. Brain studies inform AI designs that process sequences. AI tools feed back into experiments, that probe new regimes. This cross-pollination is not a metaphor. It is how methods and instruments move knowledge forward when no single field can carry the whole load. Underneath the details sits a common thread: time, as we feel it, may be a mode of access rather than the base layer of reality. The block universe remains a strong model for relating observations across frames, explaining why clocks disagree, and tying the arrow of experience to entropy and records. Yet even the block could be an interface to deeper structures, informational, computational, or relational, in which before and after are not primitive. In that setting, what consciousness reports as flow is the local story of how systems like brains write, read, and integrate records along their world lines. While other organizations of experience may be possible in principle, if these lines of work keep advancing, they will not just answer technical questions, they will reshape ordinary assumptions about meaning, mortality, and purpose. A species that understands its place in space-time differently may build new practices for decision-making, care, and learning practices tuned to agents who act under limits inside a larger structure that does not share a universal now. The next step is to spell out what such practices look like in detail and how we would test whether they actually improve judgment and well-being under real-world constraints. How do we teach children to live well if reality might be timeless? How do we keep purpose and drive if the future already sits inside space-time as a fixed pattern? These questions get sharper as technology inches toward tools that can bend our sense of time, and someday may even touch its structure. If people learn to step along their world lines in unusual ways, or to set up paths that loop like closed time-like curves near extreme gravity, they will need habits that keep judgment steady when past, present, and future interact in complex ways. Education can start by making time a topic, not just a backdrop. Children can learn that clocks measure processes, that now is local, and that different observers can disagree about simultaneity without anyone being wrong. Simple demonstrations, like clocks, GPS corrections, videos of particle decays, show that time depends on motion and gravity. Lessons can pair this with practice in agency, setting goals, checking evidence, updating plans. The aim is to link a flexible picture of time with strong skills for making choices under limits. Meaning does not evaporate if the future is fixed. It shows up as expression of values across a life's structure. Classrooms can model this by treating work as part of a path: reasons, effort, feedback, revision. Reflection can be taught as standard, not extra. Students can ask, what reasons really moved me? And what evidence would change my mind? That language trains compatibilist habits. Freedom is acting from reasons you endorse, not as a magic power outside cause and effect. When young people see their decisions as links in a chain that they help build, responsibility feels real, even in a block universe. If travel in time ever becomes practical in limited regions, say, near rotating black holes, ethics will have to be precise. A code would center on causal integrity. Never create loops that erase the records that justify your own action. Keep interventions inside your light cone, unless a proven protocol guarantees consistency. Require redundant records and independent witnesses so histories remain stable for all who share them. For personal matters, a simple rule helps. Do not use temporal advantage to remove another agent's capacity to choose. Improve options and information instead. These rules keep agency meaningful when paths through space-time get complicated. Contact with other minds could widen our sense of time. If we meet civilizations that evolved under different skies and constraints, their biology and culture may model temporal order in ways we have not imagined. Some might experience the block more directly, with less need to build the strong felt flow we rely on. They could coordinate by referencing space-time regions rather than dates, or share records through physical systems that make our schedules look slow. Exchanges would focus on methods, how to store, verify, and interpret records, how to manage agency when signals are delayed by light years, how to define fairness when observers slice time differently. Even without aliens, our tools keep changing experience. Brain-computer interfaces, targeted neurostimulation, and adaptive media already stretch the felt present and compress or dilate subjective minutes. Training can make these shifts safe and purposeful. Pilots, surgeons, and rescue teams can learn to widen the usable now under stress. Patients with trauma can learn to soften harmful replay loops. Learners can pace practice to match their brain's timing windows. The goal is not to trick the mind, but to give it reliable handles for shaping attention and memory when seconds feel long or short. The search for extraterrestrial intelligence reframes time in a practical way. Signals we send and receive are fossils in flight, old by the time they arrive. Any conversation is a dialogue between different slices of space-time. A species that can hold an eternal perspective may design messages that carry layered meaning across centuries. Self-checks, tutorials, and proofs that survive delayed reply. Training people to think this way at home, writing for readers far in the future, would help us listen and speak across stellar distances. The future of understanding stays open, even if the block is complete, because our access is local. Science keeps finding structures that sit outside everyday sense. Relativity ties time to motion. Thermodynamics gives the arrow. Quantum theory adds non-local correlations. Cosmology measures an expanding space. Each advance forces philosophy to sharpen terms: cause, information, evidence, explanation. The block universe may one day feel quaint next to a deeper frame where space-time itself is emergent. Yet the tests that lifted us this far will still guide us. Build models that predict, design instruments that can falsify them, and keep data and methods public. Consciousness stays central because it is both our instrument and our subject. It makes measurements, builds models, and asks where it fits inside those models. As technology improves, we may see new forms of consciousness, artificial systems that integrate information over long spans, human minds trained to hold wider presence, hybrid teams where biological and digital agents coordinate timing. These will give fresh tests. If an AI reports a stretched now, and we can correlate that report with measurable integration across time, we learn something about the link between felt flow and information structure. If meditation training shifts the bandwidth of the present, and we can map the neural changes that go with it, we learn how brains stitch time. The questions we raise about time and mind are, in a sense, consciousness asking about itself. Answers will change, not just textbooks, but practice how we teach, how we treat illness, how we design institutions that respect agents who act under time constraints. A public that understands itself as living along world lines may choose policies that protect the conditions for good decisions, education that builds metacognition, public records that keep histories robust, and health systems that stabilize attention and memory. Results from experiments still need careful sorting. Relativity is well tested, but eternalism is an interpretation. Quantum predictions are precise. but the meaning of superposition and measurement remains debated. The hard problem of consciousness sets a boundary. We can map functions, yet the felt quality remains puzzling. Theories that place consciousness near the base, panpsychism, cosmopsychism, need testable bridges to neural and behavioral data to move from speculation to science. Presentism and growing block models also persist as live options and must be judged by how well they handle the same observations. What we can say is this: the common picture of time as a single flow is not the whole story. The flow we feel may be a mode of access that brains use to manage action. The deeper structure looks like a four-dimensional arrangement, where before and after depend on motion, and where entropy and records set the arrow of experience. In that setting, consciousness does distinctive work. It binds information across short spans, forms reasons, and turns those reasons into acts. It makes local uncertainty real by limiting what data reach the present slice, even when the larger structure is fixed. From that angle, the fact that you experience anything at all remains the firmest point. Whatever the base of reality matter, information, computation, or consciousness itself, there is, right now, something it is like to be aware. That fact keeps the inquiry honest. It forces theories to connect symbols and measurements with lived time. It demands methods that respect both the outside view of structure and the inside view of experience. As tools sharpen, theories will be sorted by how well they explain and predict. Models that show how integration across time maps to reports of a moving now will gain ground. Accounts that link entropy, memory, and agency into testable cycles will carry more weight. Frameworks that treat spacetime as emergent must still reproduce the block's successes with clocks and light cones. And any claim that consciousness plays a basic role must face experiments that could, in principle, turn out otherwise. Education, again, becomes the lever we can move today. Teaching children that reasons matter, that evidence can change minds, and that fairness requires good records, prepares them for any future theory of time. It also builds resilience if technology changes how time feels. A culture that can hold both the eternal and the local can plan across generations without losing the urgency of the present. That stance will be vital if we ever learn to move along time in non-standard ways, or if we meet others who already do. The path ahead is not a script to follow, but a set of constraints to respect and possibilities to test. What remains is to identify the next experiments, the next educational designs, and the next safeguards for minds and records, so that as theories deepen, our capacity for clear action deepens with them. Consciousness remains the central unknown at the core of our inquiry. Whatever the base of reality turns out to be, matter, information, computation, or something we do not yet name, there is a plain fact available without theory. Experience is occurring. There is something it is like to be aware, to hold a question, to notice a sensation, to follow a line of reasoning. This minimal datum does not settle arguments about time or physics, but it anchors them. Any picture of the world that cannot account for the presence of experience is incomplete. Different frameworks describe that presence in different ways. In one, consciousness moves along a world line, sampling slices of a block universe that already contains all events. In another, observation helps shape which physical outcomes appear in records. In a third, awareness is the intrinsic side of organized information, the felt aspect of integrated cause and effect. In a fourth, consciousness is basic, and physical law is how its regularities present themselves. These options disagree on foundations, yet each must explain the same simple fact. At a given place and time, there is an observer for whom a world is present. It is possible that final answers remain outside our reach. Time may not flow in the way it seems to, and consciousness may not fit neatly inside current physics. Still, the work does not stall. We can separate what is well supported from what is speculative. Relativity links time to motion and gravity. Thermodynamics ties the arrow of experience to entropy and records. Quantum theory predicts outcomes with high precision while leaving interpretation open. Neuroscience maps the machinery that builds the felt present and shows how altering that machinery changes the sense of flow. Each layer adds constraints that any full account of mind and time must respect. From the agent's point of view, the certainty of awareness carries practical consequences. If experience is the field in which reasons are weighed and actions are chosen, then building better reasoning matters, even in a fixed space-time. Clarity about evidence, attention to bias, and deliberate practice do measurable work. They shape which records come to exist later along a life's path. Whether we describe that path as unfolding or as laid out, the links between reasons and results remain the basis for responsibility. Meaning does not require a globally open future. It requires a fit between values and action. On a compatibilist view, freedom is the capacity to act from reasons one endorses under accurate information and without coercion. That capacity can be trained. It can also be damaged. Education, health, and fair institutions protected by stabilizing attention, widening options, and keeping public records reliable. These are concrete levers that do not depend on metaphysical certainty about temporal flow. The same stance applies to inquiry itself. Models are provisional. They earn trust by predicting, by surviving tests, and by integrating with other results. The block universe is one such model. It explains why observers disagree about simultaneity and why precise systems must correct for those differences. It fits with the thermodynamic arrow through the role of records. It gives a clear place for agency as a structure of information and control along world lines. If a deeper framework later shows how space-time emerges, the block will become a special case in that wider account, much as Newtonian mechanics remains within relativity at low speeds and weak gravity. Awareness, however, will still require mapping on both sides. On the outside, we will need measures that track when and how experience is present, signatures of integration, complexity, and effective information across space and short windows of time. On the inside, we will need careful reports about what it is like when the felt now widens or narrows, when sequence fragments, or when attention holds steady under load. Linking these views is slow work, but it is the path by which a theory of consciousness meets evidence. This approach also reframes the old tension between eternity and urgency. If all events exist in space-time, the agent still works under limits: finite data, finite time budgets, finite energy. Uncertainty at the agent scale is real, because access to later records is blocked by causal structure. Planning, learning, and care remain necessary. The weight of a decision does not vanish because a larger geometry exists. It rests on the fact that reasons and outcomes are connected by causes that pass through the present slice. What we can hold with confidence is modest and useful. Experience occurs. Time, as measured by clocks and coordinated by light signals, is frame-dependent. The arrow we feel tracks where records can be formed and read. Information is preserved and transformed by physical processes that can be modeled and tested. Within those constraints, minds build present moments, link them into narratives, and act. The details of how awareness arises, emergent, fundamental, or dual aspect, remain open, but the constraints narrow what a successful theory can claim. This leaves a simple task for practice. Keep models honest by testing them. Keep agency healthy by training attention and reasoning. Keep records trustworthy so that memory and prediction have firm ground. Hold both standpoints at once. When possible, the structural view that locates events in space-time and the first-person view that navigates from a single coordinate with partial information. Neither cancels the other. Together, they make the work intelligible. The present fact remains. There is awareness reading these words. Whether that awareness is moving through time or indexing a fixed structure, whether it is a feature of organized matter or the base from which matter appears, its presence is the starting point for any further step. From this point, inquiry continues by the same method that has carried it so far: careful observation, clear argument, and a willingness to revise pictures when evidence requires it.